Okay, so in this video, I'm wanting to show you how to find sine, cosine, and tangent of these special angles. All right, these are going to be some special angles that are worth memorizing. All right, so you know sine of 45 is 0.707, but I'm wanting to show you how to get the exact answer. This is the decimal answer, and I want to show you how to get that it is the same as root 2 over 2. All right. Notice root 2 over 2 is also 0.707. This is the exact answer. Root 2 over 2 is the same as sine of 45. Okay. The way you get this answer is we're going to start with a right isosceles triangle. All right. So let me just put on here. These are the exact answers or the exact form for different trig functions. I'm going to start with a 45, 45, 90 right triangle, which is just an isosceles right triangle. Now, I'm saying that they have a legs of 1. It doesn't actually matter if this was a 1 or a 2. It all plays out the same and gives you the same answers for sine, cosine, and tangent. Well, if these are 1, we could use the Pythagorean theorem to figure out that this is square root of 2. And from this, now we can find sine, cosine, and tangent of 45 degrees. All right, sine of 45 would be opposite over hypotenuse, which is 1 over root 2. And if you rationalize the denominator, multiplying by root 2 over 2, you're going to get, root 2 over root 2, you're going to get root 2 over root 4, which is just 2. Okay, so that's why the sine of 45 degrees is the same as root 2 over 2. Cosine, hopefully you see cosine will be the exact same answer. Okay, it's adjacent over hypotenuse, which turns out to be the exact same. Okay, this is the only angle where sine and cosine are the same thing. So 45 degrees, sine and cosine are equal. Now tangent of 45, we kind of already knew this. This one's super easy. It's opposite over adjacent. So tan of 45 would just be 1 over 1 in this case, which turns out to be 1. Cool. All right. To find the 30 and 60 degree ones, we're going to draw a 30, 60, 90 right triangle. And there's some special relationships here between all these sides. We'll see what they are, but you may already know them from geometry. Okay, this will be my 30 degree angle, my 60 degree angle. And I'm just going to start with one side. I'm going to start with the hypotenuse, and I'm going to call it a 2. Okay, making it a 2 is going to make all these other numbers come out to be nice numbers. All right, so let's say I'm solving for this side over here. Okay, if I want to know what this side is, I would use sine of 30. Okay, so sine of 30 will give me the opposite over the hypotenuse. We'll just call it x over 2. And sine of 30, if we see what that is in the calculator, sine of 30, it's just equal to a half. It's 0.5. So it would be 1/2 is equal to x over 2, which means this x right here must be a 1. All right, that's the only way that these two expressions could be equal. Okay. So we can get from this picture that sine of 30 is opposite over hypotenuse, or we kind of knew it already, right? Sine of 30 was just 1/2. Now, to figure out this missing side down here, we would use the Pythagorean theorem. So I would say something like 1 squared plus b squared is equal to 2 squared. Okay, b squared would equal 3 because you got 4 here and you're subtracting 1. So b would just be the square root of 3. So this side right here is going to be the square root of 3. right, now that we have our full triangle built, we would be able to find sine, cosine, and tangent of 30 degrees or 60 degrees, just depends on which one you want. Let's say we're from this 30 degree. If we want to know the cosine of 30 degrees, it's going to be adjacent over hypotenuse, which is root 3 over 2. So cosine of 30 is going to be root 3 over 2. Let's go ahead and do tangent while we're here. Tangent of 30 would be 1 over root 3. Excuse me. Tangent of 30 is 1 over root 3. And if you rationalize the denominator, you're going to get root 3 over 3. Excuse me. So you'll see tangent of 30 represented both ways often. They might write it like this, or they might write it like that. So I'll go ahead and put both of them, down. It's 1 over root 3 or root 3 over 3. From the 60 degree angle, if we wanted to do sine of 60, actually we need to do all of them, don't we? Sine of 60 is going to be opposite over hypotenuse, which is going to be root 3 over 2. Cosine of 60 would be adjacent over the hypotenuse, which is going to be 1/2 again. And then tangent of 60 would be opposite over the adjacent, which is just going to be root 3 over 1, which will simplify down to just root 3. All right. These 9 right here, these are going to be your main ones, right? Now, a lot of times, just to make it easier, hopefully you see a pattern here. They all have a denominator of 2, right? So what I like to do is just call this root 1 over 2, which is the same as 1/2, but there's a nice little pattern in the numbers now. It's root 1 over 2, root 2 over 2, root 3 over 2. And for cosine, it's the same thing, but counting down. Okay. Now, usually on tangent, I'm not gonna say that I have them totally memorized, although I do. But to figure out what tangent of 30 degrees is, it's usually easier just to do sine over cosine. If you imagine the sine over the cosine here, the 2's will just cancel, and so it's leaving you with the root 1 and the root 3, just like this. Okay. Or if it was tangent of 60, all right, it would be root 3 over root 1, which is just root 3. Okay. So let's go ahead and complete this table. We need to do the 0 degree angles. Hopefully you see the pattern already. The pattern is just, root 1 over 2, root 2 over 2, root 3 over 2. So for sine of 0, it's going to be root 0 over 2, which is just 0. And for sine of 90, it would be root 4 over 2. Just 0, 1, 2, 3, 4, which is just going to turn out to be 1. Okay. And you can confirm these on a calculator if you want. Sine of 0 is 0. Sine of 90 is 1. Okay. Cosine, it's going to be 1. And then cosine of 90 is going to be 0, just like the flip-flop of the sine one. For tangent, you're going to have to use your sine over cosine definition. So for tangent, we'll do 0 over 1, which is just going to be 0. And then for tangent of 90, it's going to be 1 over 0, which is undefined. Or a lot of times you might just say infinity. Right? So these are the exact forms for the trig functions. You can still reach for your calculator to see what they are in decimal form, like tangent of 60. Tangent of 60 will give you this 1.73, but the idea is that it's the same as the square root of 3. Okay. If you look at the square root of 3, it's the exact same answer.